Okay, we're going to look at the problem which was on the first exam last year. This was one of the more challenging problems that students faced. So let's take a look. It says question 4, 20 points out of 100. So that was a pretty big question in the exam. And let's read the instruction. It says, assume you are sending a 40 megabit file from a source host to destination host. All links in the path between the source and destination have transmission rate of 10 megabits per second. Assume that propagation rate is 2 to the 10th to the power of 8. 2 times 10 to the power of 8 meters per second, and distance is 15,000 kilometers. In the question A, suppose there is only one link between the source and destination. Also suppose message switching is used, with message consisting of entire MP3 file. What is the end-to-end delay? How many bits will the source have transmitted when the first bit arrives at the destination? Show your work. So we're going to leave the part B for later, and let's work on part A now. There are two questions. What is the end-to-end delay, and how many bits will the source have transmitted when the first bit arrives at the destination? So let's try to answer the first question. Problem statement says we have source and destination, and we have one link between the source and the destination. Source is supposed to send an MP3 file. The link rate is the transmission rate of the link is 10 megabits per second. The length of the link is 15,000 kilometers, and the propagation of this medium is 2 to the power of propagation rate of this medium is 2 to the power of 8 meters per second. Now, since there's the first question says, what is end-to-end delay? End-to-end delay is a summation for each link of the 4 different delays. The first one is processing. The second one is queue delay. The third one is transmission delay, and then the final fourth one is propagation delay. Now, since there's nothing in the problem statement regarding processing, so we are going to say that this is insignificant, and we're not going to worry about. There's also nothing in the problem statement about queue delay, so this is also insignificant, and we're not going to worry about that one. And since there's only one link associated with the problem, we're not going to worry about summation. Answer to the first question, which says what is end-to-end delay, is the following. So end-to-end delay is equal to transmission plus propagation delay. And when we put numbers in, transmission delay is 40 megabits per 40 megabits, that's the size of the message, divided by the rate, which is 10 megabits per second, plus propagation delay is the distance, 15,000 kilometers, which is 15,000 times 10 to the power of 3 divided by 2 times 10 to the 8 meters per second. And finally, that total delay becomes 4.075 seconds. Okay, that's our final answer. The answer to the second question, which says how many bits will the source have transmitted when the first bit arrives at the destination, can look like this. So we have a source and we have a destination. There's a link between them, and the first bit of the whole message is sent. This first bit, the question is, how long does it take to reach the destination? Well, that's actually a propagation speed. So delay due to a propagation is the length of this link, which is 15,000 meters, 15,000 kilometers divided by the rate, I'm sorry, not the rate, but the propagation speed of the link, which is 2 times 10 to the 8 meters per second. So 2 times 10 to the 8 meters per second comes to a 0.075 seconds. So the question is, how many bits will be transmitted from the source node in this time? So we have to take this time and multiply by the transmission rate to get our answer. So dp times transmission time, rate, call it dr. So transmission rate is 10 megabits per second. So 0.075 times 10. I'm sorry. Let's just start this all over. So this is seconds times 10 megabit per second. So seconds and seconds goes away, and our result is 0.75 megabit. So that's how much data is sent while the first bit is traversing this link. Now let's take a look at the part B of the question 4. It says, now suppose there are 3 links between the source and destination with 2 routers connecting the links. Each link is 5,000 kilometers long. Suppose that file is broken into 4 packets, each of 10 megabit. Suppose there is no congestion, so that the packet is transmitted onto the second link as soon as router receives entire packet. Ignore headers that may be added to these packets. Also ignore router processing delay. What is the total delay? Show your work. The problem states that we have a source node and destination node. I'm gonna label them like this, and then we have 2 routers in between. I'm gonna say this is router 1, this is router 2. I'm gonna color the links between the source and router 1. Let's pick a different color. Router 1 and router 2, and then router 2 and destination. I'm going to draw a timeline that looks at what's going on at each of these nodes. And so the source has 4 packets to send, and so this is how it looks like. This is 0 time, and this time is flowing from top to bottom. From source, first packet is sent. There is some propagation delay and some transmission delay. After our router 1 receives a packet, only then it's able to transmit that packet onwards. So the packet 1 will be only transmitted on this pink route after it's completely received by the router 1, and so on. The same thing will happen on router 2. Once that packet 1 is received, the packet will be forwarded to the destination, and so on. So I will complete this diagram. This is packet 2, 3. Okay, so let's see what delays are involved. So when the source sends a packet to the router 1, there is a transmission delay, and then there's a propagation delay. But for this timeline, we'll count all the delays there exist. So the next delay is again transmission delay. Transmission delay, that's from this point to that point. Then transmission delay from this point to that point. And then propagation delay from this point to that point. And another transmission delay from here to there. And then propagation delay from this point to that point. And then another transmission delay from this point to that point. And the propagation delay, final one, is from this point to that point. So our total delay is actually the time it takes for these 4 packets to be sent from the transmitter or the sender, and that they would be fully received by the destination node. So let's go and collect our times. So that's 1, 2, 3, 4, 5, 6 times the transmission delay, plus 1, 2, 3 times propagation delay. We put that into numbers, so that's 6 times transmission delay is our size of a message, which is 10 megabytes divided by, 10 megabits divided by 10 megabits per second, plus 3 times the length of the link is, that's 5,000 kilometers. That's 5,000 times 10 to the 3 meters divided by the speed, which is 2 times 10 to the 8 meters per second. And then our total delay becomes, when all these numbers are calculated, 6.075 seconds. That's our final results.